Alrighty, so we are now at Unit 2, Concept 2, Cellular Transport. So in the first concept, we were talking about the cell theory and the many different organelles that work together to perform the daily roles, the daily functions, the daily necessities that the cell needs performed every single day. And so, in particular, with this concept, we're going to be focusing on the cell membrane, the plasma membrane. Remember that barrier between the inside of the cell and the outside of the cell. Okay, and remember that the cell membrane is kind of like, I remember I use this analogy, it's kind of like a bouncer at a nightclub, a bouncer at a party, or someone standing at the door. They are the ones that are deciding who to let in and who to not allow in, or who to kick out, so to speak. And so a cell membrane, its role is a lot like like a bouncer at a nightclub, and it is a very, very important role because in order for a cell to function, in order for it to perform everything that it needs to do, there is a very specific set of requirements that have to be met in order for it to do its job. And so, what do I mean by that? Well, it's a big fancy word and it's called homeostasis. So, every organism needs to maintain and regulate constant or stable internal conditions. And so, think about it in terms of your own body. How does your own body regulate itself, as in maintain homeostasis? Your body regulates itself. It regulates its temperature, your internal body temperature. It regulates your pH, which is just the acidity of your blood. And it also regulates the concentration of other materials and nutrients that must be maintained within a relatively narrow margin. And so, I'll get to that last one in just a second. I want you to think about it in terms of, like, let's say you're sitting at home and your parents have a very specific belief on what degree the thermostat should be set in. And I'll go ahead and guess it's somewhere between like 60 degrees and maybe like 80 degrees, depending on whether it's winter or whether it's summer. And I mean, maybe your family is different. I mean, you guys, you do you. If you let it go lower or higher than that, I'm a very hot person, so I could not keep my house at 80 degrees. I keep it at a nice, comfortable 73 degrees because that is what works for me. But again, I mean, I'm the one paying the bill, so your parents are the ones paying the bill. They get to set the thermostat. Okay, so your body, in this case, your body's just gonna have to adapt to that. But no, okay. So 60 to like 85 degrees. So let's say you're sitting at home and let's say you're like me and you get really hot easily, but yet you don't have any control over the thermostat. Your parents set it to 80 degrees. Okay, so let's think about this. You're really not going to want to do many things around the house. You're not really going to want to get up. You're not going to want to do chores. You're not going to move around a lot, because moving around a lot, you're going to get sweaty, you're going to get hot, and you're going to get tired, because the thermostat is not set to your desired level of comfort. For me, that would be about 73, 72 degrees. And so that is about the sweet spot where I would be fully comfortable getting up, doing laundry, cleaning a little bit. That is where my homeostasis would be met and I would be a-okay happy. However, on a cellular level, much of homeostasis is maintained by the cell membrane, controlling the movement of things into and out of the cell. Okay, so that cell membrane, bouncer at a club. So this is what the cell membrane looks like. This was the fluid mosaic model that I showed you earlier. Okay, and so the cell membrane is said to be, we call it selectively permeable. Okay, so selectively permeable. And this means that certain substances can move across it freely, while others must pass a gate. So the people at the club that are nicely dressed, they have their blouses on, their dress shirts. They got nice shoes. The girls are wearing either nice slacks, pants, or nice dresses, and they just move across freely. They collect $200 as soon as they hit go. While others must pass a gate. Maybe they aren't on the list. They're nicely dressed and all, but they're not on the list, so they have to sign in before they're allowed to enter, whatever the case may be. And so, let me move this. Transport of materials across the cell membrane can be classified as one of two ways. They can be classified as either passive transport or active transport. So, passive transport requires no extra energy from the cell because molecules move from high concentration, meaning they're squished together, and they move to areas of low concentration where they're able to spread out and kick their feet up and relax. And we call this moving down the concentration gradient. Okay, I'll repeat that again. Passive transport requires no extra energy by the cell because molecules move from high concentration, where they're really packed together, to areas of low concentration where they can spread out, kick up their feet, and they are said to be moving down the concentration gradient. And so think about this in terms of if you were to be, let's say you're in New York and you're about to ride the subway, and you walk in and the subway is empty. You go and you sit at whatever seat your heart desires because there's no one else there. And at the next stop, one person gets on. Now, it's actually funny because in America, I'm sure all of you could guess, that person, do you think they would sit right next to you? Every other seat's open. What do you think? Would they sit right next to you, or would they like maybe sit as far away as possible from you? If you said as far away as possible from you, you'd be correct. And it's just funny. I couldn't really use this example if we were in another country because it's actually very not specific to American culture. I mean, there are a lot of other countries that are very much like us where we like our personal space, but I can't think off the top of my head of some examples, but there are other countries where it would not be weird, it would not be rude, it would not be freaky at all if someone went and sat down right next to you, even though every other seat was open. In America, that would be weird. I would be weirded out, I'd be freaked out, I'd be like, whoa dude, like there's like a million other seats and you chose the one right next to me. I don't like that. Okay, so that is not what's happening here when we're talking about passive transport. Think about passive transport as our American culture. Someone comes in, enters that subway, they're going to sit as far away as possible from you because they want to minimize the amount of human-to-human interaction. That is America. Okay, passive transport. All right, then the second type of transport is called active transport. Let me just move that down a little bit. And active transport requires extra energy, which is in the form of ATP, to be spent to bring materials into the cell or to expel materials out of the cell, moving from low concentration to high concentration, and we call this moving against the concentration gradient. So they are moving from an area of where they can kick their feet up and relax, and instead of relaxing, they decide, I'm gonna go join that party over there where everybody's squished and no one really has any room. That's what I'm gonna do. So think of it like boarding a crowded subway, okay? You're gonna have to push through people, you're gonna have to squeeze together, there's gonna be standing room only, and it's gonna require that extra little bit of energy in order for you to actually get past all of those other people. Okay, so this is just a chart of the examples of the two types of transport. So passive transport has two types: simple diffusion and facilitated diffusion. Okay, and then a specific type of diffusion is called osmosis, and we will go into depth on what these mean, but I just wanted you to see this chart. Okay, and so then the types of active transport are molecular pumps and exocytosis and endocytosis. Okay, so just kind of make sure you get this chart down, and we will go into depth about all of these. All right, just some words to know. So a solute is what gets dissolved when you're talking about solution. So the example here is lemonade powder. When you're pouring lemonade powder into water, the lemonade powder is going to dissolve. It's going to expand and try and be surrounded by all those water molecules. So the water is going to encompass it, is going to dissolve it. Okay, and so solvent is a substance that does the dissolving. So in this example, it would be water. And if you recall from Unit 1, water is a terrific solvent. It is known as the universal solvent because it is so good at dissolving other substances. So sugar, lemonade powder, chili powder. I don't really know if it would dissolve chili powder, but probably it is such a good solvent. So somebody look that up. All right, the third term we need to be familiar with is what a solution is. And a solution is a uniform mixture of two or more substances. For example, so in this example, it would be the lemonade. Sorry, I'm just going to move it up a little bit. Would be the lemonade. Oh, and I got to move this anyways. Okay. All right, so uniform mixture of two or more substances. So yeah, once you finally mix the water, the solvent, and the lemonade powder, the solute, you will get a solution, which is a uniform mixture of the two. All right, then the fourth term is concentration. And this is that word means the amount of solute that is dissolved in the solvent. So let's say you poured in, I don't know, 50 grams of the lemonade powder, and you were looking at 100 milliliters of water. So you would be looking at that there would be 50 grams of the solute, 50 grams of lemonade powder, within 100 milliliters of water. And so that would be called a concentration. And the symbol or the abbreviation for concentration are these two, can't think of what these are called, like the weird parentheses, the boxy parentheses. I'm sure someone will tell me what they're called. Yeah, so if you ever want to abbreviate that, that's what you would put. And you could also, you'd put this, you could put lemonade inside here, and it would be the concentration of lemonade, or you could put the concentration of lemonade powder, the concentration of water, whatever it was. You just put brackets. That's what they're called. Wow. All right, that was really late. You put them inside the brackets.